Okay, so today we're going to do 8.2, which is solving two-by-two system by substitution and elimination. Have you seen this before in Math Class 15? Okay, so it will be more like a review for you, I hope. Okay, and let's just start when you're ready. All right. So basically, I'm recording the session. Hopefully, I have a recording by the well. Usually it takes this to this day, but if you're here, you probably don't need it. But I will make it available anyway. And you're, as usual, you're just going to take notes and everything. So just ignore the recording that you're being recorded. Take notes as usual. Okay. And if I'm too fast, let me know. If you have questions, let me know also. Yeah, it's okay to interrupt recording. If you need clarifications, you could do anything you like. You could ask me, you could interrupt me, etc. Yeah? All right, now this section, 8.2, is very, very, very important. So you're going to use this a lot of times, whether you like it or not. Usually people like it. Yeah. All right, so let's start. I'm going to share my desktop. And well, sharing desktop. Okay. All right, so 8.2, substitution and elimination method. So, substitution and elimination. We usually start with substitution because the elimination part of the elimination is substitution also. Okay, so now let's start. All right, let's see. So A is substitution. Maybe it's better for me to sit down. Substitution method. So let me just give you an example right away, and then after one example, we could write down what we're supposed to do, what actually happens when we perform substitution. So the first system is x equals to 8 minus 4y. And the second one is 3x plus 5y is equal to 3. So we will call this equation 1, and we will call this equation 2. And we will use this type of calling names. Do you see how I label my equations? What did I do to label my equations? I put dot, 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 and then 1, right? So we're going to make it a habit to label our equations if it is more than 1. Do you know why I put dot, dot, dot? Why don't I just instead do this? Instead of labeling it dot, 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 I'm just going to do this. Why not? Yes, what's your name? Jonathan. Yeah, looks like this is 4y multiplied by 1. That's why when I label, I always use dot, 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 1. Yeah. Now this is a good time to start using the labels because the next section will be 8.4. It's 3 by 3. So we have a lot more equations. All right? Okay, what do you think we will do here? The goal is, so remember, the goal is to have one equation, one variable. So I will substitute x equals 8 minus 4y to equation 2, right? So substitute x equals 8 minus 4y to equation 2. Why would I do that? Because I want one equation with one variable only. So when I substitute, what do I have? 3 times 8 minus 4y, right? I no longer use x. I replace x by 8 minus 4y. plus 5y is equal to 3. Yes, perfect. Yeah. So 24 minus 12y plus 5y is equal to 3. All right. So now look at my equation. Do I have x or y here on the first one? This equation. How many variables do I have? I only have one, which is y. That's the goal of substitution. So the goal of substitution is to make one variable only in one equation. So I don't have x anymore. Now I can solve it, can I? All right. So how do I solve it? Combine like terms? Okay, negative 12y plus 5y. Negative 7y. Okay, what do you do to the 24? Subtract 24 both sides. What is 3 minus 24? Negative 21. So you could write minus 24 both sides if you like. But if you write it, make sure you write it to both sides, not just one. Yeah. Or you don't have to write the minus 24 both sides. So either way. Yeah. So what is y? 3. All right. Good. Are we done? No, you have to solve for x. So how do you solve for x? Yes. So substitute. Plug in a substitute, right? So y equals 3 to which equation? Equation 1, because it's easier. Can I do equation 2 instead? Yeah, but equation 1 is easier. So we choose which one, the easier one or the harder one? Oh, of course, yes. So this one is x is equal to 8 minus 4 times 3. So what is 8 minus 12? Negative 4, right? Okay. So what is my solution? In ordered pair? Negative 4, comma 3. Now in Math Excel, if you're asked to write down an ordered pair, remember to put the parentheses, because the ordered pair contains parentheses. So it's going to say, enter your answer as ordered pair. So you're going to include the parentheses because your ordered pair comes with parentheses. Have you seen this before? Anybody have not seen this before? Everybody has seen this before? Yes? Okay. All right, what about if I have something like this? So m minus 2n is equal to 16. And 4m plus n is equal to 1. So what am I supposed to do here first? Label, right? Dot, 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 1. Dot, 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 2. That's my label. Okay, and we're doing substitution. Now, what am I going to do next? Can we substitute right away? No, you have to solve first, right? You have to solve for a variable first, either m or n. Which one is easier to solve for? Either m here or n on the second one. M on the first equation or n. Why? Because the coefficient is 1. So how do I solve for m? So let's do that first. So solve for m in equation 1. So what is m equal to? What is m equals to? 2n plus 16, yes, or 16 plus 2n, it doesn't matter, right? And we will call this equation 3, which is equivalent to equation 1. So it's it's different equation, but they're equivalent. Equation 1 and 3 are different, but they're equivalent. Right? Now we have something to plug in into, right? Or we can substitute. So substitute n is equal to 2n plus 16 to equation 2. All right. So what do I have in equation 2? So 4m, but I'm not going to write m. What am I going to write? Yes. Plus n is equal to 1. All right. So practically, I'm only replacing m by 2n plus 16. Now what? 8n plus 64 plus n is equal to 1. Next. What do we do next? Okay, so what is that? 9n plus 64 is 1. Okay, then? Yes, so what is 1 minus 64? Negative 63. So n is negative 7. Yes. So you can write all the process. What do I mean by that? I could write minus 64, minus 64. Right? But you have to write it to both sides. Yeah. And I could also write divide by 9, divide by 9. But what? We have to write it to both sides if you want to write it. Make sense? So if on the exam I see, oh, only one side divided by 9, I usually deduct point. Yeah, because that's not true. Look at this. If I have 9n is equal to negative 63, is it the same as 9n is equal to negative 63 divided by 9? No. That's why if you decide to write it, you have to write divided by 9 to both sides. Is it okay? So either you write it to both sides or don't write it. Yeah? Okay. So here I'm going to erase this part because I don't want to write it. So I erase both sides. Now, let's solve for m. So substitute n equals negative 7 to which equation? 3. That's the easiest one. Yes. Can I do it to equation 1 and 2? Of course. But we do to the easiest one is easier. So m is equals to 2n, 2 times negative 7 plus 16, which is negative 14 plus 16, which is 2. So if you want, you can write that negative 14 plus 16, or if not, you can just write directly m equals to 2. So my solutions would be 2 comma negative 7. Right? Okay. In order pair notation. All right. Does everybody find this doable or easy? Yeah? Easy? Okay. Can you tell me then what is the goal of substitution method? So we are going to write it up now. So you get the idea, a big idea of what it is. We're going to write it in our own words, right? So, are you guys done? Yes? Okay. So substitution method. What is the goal? What do I want? What is the goal? The goal is what? Yes, but of course, that's always the goal. But what What is specific to substitution method? Find the points? Yes, but elimination method, we also want to find the points or the variables, right? What is your name? What is your name? Jose. Thank you, Jose. And what was your name? Brendan? Okay. I'm trying to remember everybody's name, so when you say something, I'm going to ask you what's your name, so I could remember, okay? Usually, I could remember after 3 weeks. But right now, I couldn't, even if I see you on the street and then you say hi, I will probably won't remember also. So don't get mad at me. Sometimes I remember, sometimes I don't remember. Yeah. Okay, so Brendan, what were you saying?
Well, find one of the variables
to Why would you plug into the others? That's the goal. Well, that's my question. Why would you plug into the others? What is it that you're looking for when you're doing substitution? That's my question. Right. So the goal is to substitute a variable by another expression to get an equation in one variable. So your goal is to get an equation in one variable. That's why we do substitution, right? That's your goal. You want to get one equation with one variable. So originally your equation has how many variables? So if I could go back here, let's see here. So look at the first equation. Has how many variables? 2. How about the second one? 2. As soon as you do substitution here in this step, what do you have? Do you still have 2 variables? No, you only have 1. So that's the goal of substitution. Does that make sense? That's your goal. That's why you do substitution, because you want one equation and one variable. Good. Now, how do you do that? So what do you do for substitution? Yes, so solve for one variable if necessary, right? Sometimes it's already solved for you. Yeah, if necessary. Sometimes it's already solved, so you probably don't need to do it. And how to make it easy? Choose the variable. So to make it easy, what do you do? Choose to solve for a variable with coefficient what? 1 or negative 1. If 1 is ideal. Sometimes they don't have, so 1 or negative 1. Right? And then you do all the substitution. So the other ones, the other method, we don't have to write down. So the key is coefficient 1 or negative 1. And what you want to do is to get an equation in one variable. All right. And then you know what to do next. So we don't have to write down. So let's do more examples. Did Miss Melanie talk about the 3 cases? Okay, so what are the first case? What is the first case? The lines, what happens to the line? They intersect? Okay, good. And then if the lines intersect, then we have how many solutions? 1 solution. Okay, good. What do we call the system? Is it consistent or inconsistent? Consistent. Consistent, right? It has at least 1 solution. And she talked about these also, right? What about the equations? Are they dependent or independent? Independent. Why do you call it independent? Yes, you have 2 different graphs. You have 2 equations and you have 2 different graphs. That's why they're called independent equations. So this is case 1. Lines intersect. So I'm reviewing a little bit. Okay, good. So what about case 2? No solution? So did she talk about 2 parallel lines then? Okay. So case 2, the lines are parallel. All right. How many solutions do you have? No solution. Okay. Yes. And what about the system? Do we call it consistent or inconsistent? Inconsistent. Why is it inconsistent? Well, I mean, there's no solution. They're not consistent. They're contradictory. Yes. How about the equations? Dependent or independent? Independent. Independent. Why do you call it independent? You have 2 different graphs. Yes. All right. Case 3. Do you remember case 3? Yeah, the lines are identical, or the lines are identical, or you could say the lines coincide. So this is the math. Coincide. Yeah. Coincide. All right. How many solutions? Infinitely many solutions. Why is it infinitely many? What do I mean by infinitely many solutions? Yes. All the points, all the ordered pairs on the line. So there are infinitely many points here on the line, right? So those are all the solutions. System? Consistent? Okay, because it has at least 1 solution, that's why it is consistent. Okay, what about equations? How many graphs do I have? Only 1, so we call it dependent equations. All right. All right. So let's do it algebraically, case 2 and case 3. So you've seen it graphically, but what does it mean algebraically? Yeah. Let's see. So for example, I have, when you're done, P is equal to 4 minus 2s. So this is s, not 5. 4 minus 2s. This is equation 1. And then P plus 2s, this is s, is equal to 6. Okay, so what am I supposed to do now? What is it? Substitute? Yes. So substitute P equals 4 minus 2s to equation 2. So let's see, what do we have when we substitute? 4 minus 2s, that is your P, plus 2s is equal to 6. Okay, then what happens? The 2s cancel, so we have 4 is equal to 6. So is it true or false? So what is your conclusion? no solution. So for whatever T and S we put in, it's not going to work. Yeah. So this is why it says it's inconsistent. Right? How can 4 be equal to 6, right? It's inconsistent. Yeah. So we have no solution. So this is case 2. If I were to draw these two lines, then I would have two parallel lines. Right? Okay. Are we okay so far? Yes? Okay. So when you're done, then I will go to the next page. Okay? So this is case 2. If we want to label this, just label this. This is case 2. What about number 1 and 2? Which case is it? Is it case 1, case 2, or case 3? So number 1 is case 1. Okay. What about number 2? Case 1. Okay. So you could label those two. Yeah. So number 1. This is case 1. So once you have a solution, we know this is case 1, and this is case 1 also. Okay. So both number 1 and number 2 are case 1. And then number 3 is case 2. Okay, so let's do number 4. What about this? So A minus 2B is equal to 3. This is equation 1. And then 3A is equal to 6B plus 9. This is equation 2. All right. What do you think we should do? Solve for A? Yes? Okay. So you can solve for either A, because I could just divide by 3 here on equation 2. So you want to solve for A in equation 1 or 2? Equation 2? Okay. So I could just divide by 3, right? So 3A equals to 6B plus 9. So divide by 3, divide by 3, divide by 3. So A is what? 2B plus 3. And we will call this equation 3. Equation 2 and equation 3 are equivalent. Then what? Substitute A equals 2B plus 3 to equation 1. So we have 2B plus 3 minus 2B is equal to 3. What happens here? Yes, 2B cancels out, so we have 3 equals 3, which is what? Which is true or false? Okay, which is true. So is this a little different from the one we had before? What happened? What's the difference? For number 3, what's the difference? This is 3 equals 3, which is true. What about the other one? That was false. So that the other one has no solution. What about these? Infinitely many solution, but what are they? You said infinitely many, but what are they? But yeah, you said how many solutions do we have? But what are they? Yes. Okay, so remember, what are the solutions? If I only have one line here, what are the solutions? all the ordered pair on the line, right? So how do you write it mathematically? I'm not using xy here. I'm going to write a comma b, right? Such that. So basically what I'm saying is my solutions are all the ordered pairs on this line or on this line, right? I have two different lines. So this is how I write it mathematically. It's all the ordered pair a comma b such that a minus 2b is equal to 3. Okay. Or I could write down the other equation, a comma b such that 3a is equal to 6b plus 9. Because they're the same line anyway, I could write the equation 2 instead of equation 1 here. Yeah. So basically, it says the solution is all the ordered pairs on the line a minus 2b is equal to 3. That's what it says. Yeah, but you have to be able to write it mathematically. So if you write it mathematically, it's going to look like this. All the other ordered pair a comma b such that they fall on this line. Doable? Can you tell the difference between number 4 and number 3? Yes? Okay. All right. Why don't I use the other equation? Why do I use the first one? No, you can actually write down the second equation as well. Yeah, they're the same equation. They're the same line anyway. So I could erase this and then put in 3a equals 6b plus 9. So it doesn't matter which equations we use. You know why? Because they're equivalent. They're the same, right? So it doesn't matter whether I use equation 1 or equation 2. Yes? Okay. Good. Now, I'm done with substitution. We should do elimination, right? Any other questions on substitution? Are we okay so far? Okay. So I'm going to start elimination. Yeah. Elimination method. All right. Okay, so we'll do a few, and then you're going to tell me the goal and the steps. All right. So suppose I have x plus y is equal to 9, and 2x minus y is equal to negative 3. All right, and we're doing elimination. We're no longer doing substitution. So we label the equations as usual. Okay. Then what? Can I just add this? Yes. Okay, so ooh, life is easy, isn't it? We can just add. So what is this? 3x is equal to 6. Okay, so x is equal to 2. Oh, life is easy. All right. Now, how do I solve for y? Yes, so substitute x equals to 2 to equation 1. So what do I have here? 2 plus y is equal to 9. And what is y? 7. And then we are done. So what is my solution? 2, 7. So we follow alphabetical order. If you have m and n, then m, n. If you have A and B, then it's A comma B. Right? S and T is S comma T. All right. Good. Yeah. All right. What about the next one? All right. You guys ready? So number 2. What about if I have 3x plus 2y is equal to 3 and 9x minus 8y is equal to negative 2? One and 2. All right. Am I going to add? No. Why don't I add? Because I do not eliminate any variable. So your goal, what do you do when adding? So the goal is to eliminate variable when we add. So now we know the goal of elimination method, don't we? So elimination method. Okay, so let's write down the goal is to eliminate one variable when adding two equations. I'm just going to write when adding two equations. So that's your goal, right? So we're not going to add here. Why? Because we don't eliminate any variable. So what are we supposed to do first? So you're going to look at your numbers here, your coefficients, and you're going to decide which one do you want to eliminate. Which one? Y, okay, or X, it doesn't matter. So we decide a variable to eliminate. So let's just say we want to eliminate Y. Can we eliminate X? Yes. So what are we doing? If we want to eliminate Y, what are we going to do? Yes, so we want the least common multiple, the LCM. Okay, so what we want to do, let's write it, we want to eliminate Y. So I usually write it. And what do you do to equation 1? Multiply by 4. Yeah. Right? What do we do with equation 2? We just copy it, right? Okay, so is everybody clear why we have to multiply equation 1 by 4? Any questions with that? No? Okay, so the least common multiple is 8, right? So 12x plus, multiply by 4, what do we have? 8y is equal to, multiply 3 by 4, 12. So every term is multiplied by 4. The equation 2, we just copy. 9x minus 8y is negative 2. All right. Can we add now? Well, yes. So you have 1 plus 1 negative and the same coefficients, opposite signs. So we could add 21x is equal to 10. All right. How do we solve for x? Divide by 21 both sides. So you could write it if you like. So what is x? 10 over 21. Yes? Okay. Can we make it smaller? Can we reduce this 10 over 21? No, so we're good. So how do we solve for y? Yes, substitute x equals to 10 over 21 to equation 3. Oh, equation 1. We don't have equation 3, do we? All right. So what do we have when we substitute? So 3x 3 times 10 over 21. So your x is 10 over 21. Plus 2y is equal to 3. Yes.
Okay. I'm not going to I had a student who got lost with some of his equations, so I was just showing her.
Okay, this is G51. Are you an FYE? No, this class.
FYE program?
Yeah.
Okay. All right. I'll be
Thank you. Okay. All right. So let's continue. What are we doing now? Can we do something here? Can we cancel common terms? Yes. So this is 7. This is 1. So this is 10 over 7 plus 2y is equal to 3. All right. Now there are many ways to do it. You could bring the 10 over 7 to the other side, or you could get rid of the fraction. You could clear the fraction. How do we clear the fraction? Multiply each term by 7. Yes. So maybe that's easier. Or you could, of course, if you like to work with fractions, you could bring it to the other side. No problem. So 10 plus 14y is 21. All right. So 14y is equal to, what is it? 11? What is what? All right. So we have 10 over, oh, I have to write in order, right? 10 over 21, comma, 11 over 14. That's my solution. Okay. All right. So now let's go back and write the steps here. So you know the goal. When you add, you have to eliminate a variable. Okay. So what do you do to eliminate the variable? So find the least common multiple of the coefficients of the variable we want to eliminate, right? That's what you want to do first. So if you have 2 and 8, then you want, what is the least common multiple here? 8. So that's why you're multiplying the first equation by 4. So after you find the least common multiple, then what do? Multiply both one or two equations, one or both equations, so that the coefficient of the variable, which variable? The variable to eliminate, to be eliminated, is the LCM and its opposite. So it has to contain opposite signs. Yes? And then you can add. When you add, then add the two equations. The two equations. And etc. Right? So, all right. Now, what I want to do is I want to give you a few problems, and I'd like you to work on it. Yeah. What do you think? This is pretty easy? Doable? Yeah? Okay. So, let's see here. So, are you guys going to get Math Excel pretty soon? Today? Oh, you already got it? Okay. So, they have your names yesterday, since yesterday? Oh, okay, good. Yeah. So, just in case you just register or something like that, you are a new FYE student, call the office. When you're there, call the office, just unless they give you a lot of trouble. I hope the bookstore doesn't give you any problem. Yeah. All right, good. Now, I'd like you to work on this. Number 3. 2x over 3 plus 3y over 4 is 11 over 12. Okay? And then, number 4, 10a plus 6b equals to 8. Oh, there's another one. X over 3 plus 7y over 18 is equal to. So 2x over 3 plus 3y over 4 is equal to 11 over 12. X over 3 plus 7y over 18 is equal to half. And this is 10a plus 6b is equal to 8. 5a plus 3b is equal to 2. Okay. Now, are you going to work with fractions? So look at number 3. You have fractions. What would you do first? Get rid of it. You have to clear the fractions first, right? Why would we want to work with fractions if we can eliminate the fractions? Yeah. Okay. So what would you do to eliminate to clear the fractions? What would you do? Yes. What is the LCD? 12. So I'm going to multiply 12 to both sides. So 12 to the left side, 12 to the right side. Yes.
Multiply our equation number 2, multiply 2.
Mm-hmm.
Both sides of the equation, and then you'll be able to eliminate 4x over 3.
Yeah, you can, but then when you add these, you still work with fractions. You have 3y over 4 plus, actually it's going to be minus 14y over 18, right? So yeah, you can multiply the second equation by -2, right? But still, you are going to work with fractions because when you add these two, then you work with fractions. Does that make sense? So it's probably easier to clear the fractions. Yeah? So we want to do it. We want to clear the fractions. Okay? All right. So when we clear the fractions, what do we have here? Oh, this one cancels. It becomes 4. This one cancels. It becomes what? 3. And this one also cancels. Maybe I should give you time to do it? Okay? All right. So, and then let me write number 5. Negative 0.4x plus 0.7y is 1.3. And then 0.7x minus 0.3y is 0.4. All right. Okay. Okay, so I'm going to give you 5 minutes so that we could discuss it. We have time to discuss this. Okay. So you will clear the fractions first. Okay, so what's your name again?
Daniel.
Daniel Rodriguez. Okay, try to remember this. You are Brandon Perez?
Yes.
Okay. And you're
This
this
is
is Hallelujah.
yes.
You are?
Alright.
Okay.
Alright.
Oh, I didn't see it on here? Oh, so you're gonna have like, okay, and you have it. Okay. Oh, you're late, yeah? So I didn't call it in the beginning. I'm recording, I'm supposed to be before. So around what time? 10, it's almost 10:30? Usually around 10:31, 10:30. Or so our Tuesday? Okay. So today I memorize the first one. Okay, next time we have next one, okay?
Well, I mean, you can change seat. I'm not saying you have to stay the same. So, Daniel, Brandon, Jesus, and then he's new. And Frank, right?
Yes.
And then Hector, and then Joe. Are you done? Or do you just want to discuss it? No, you need to work on it a little bit. Yeah. So for number 5, what would you do also? Get rid of the decimal, right? For number 3, we are clearing the fractions. For number 5, we are clearing the decimal. We want to make our life easy, don't we? Yeah. Why does it have to be so hard? So those of you who got F slips from me, you guys need to process that. Did anybody process that? Oh, only 2. Is the section correct? 8526. I don't need it. Just make sure it's 8526. Section number?
Yes.
Okay, then you're good. All right, so let's discuss it because we should end at what time? 11:40. Okay. So what's the first equation here? If I clear the decimal, the fraction, 4 times 2x, right? Yeah. So 8x plus 9y is equal to 11. So this is my first equation. I'm not gonna label my fractions. So this is my label, 8x plus 9y equals to 11, because that's what I'm going to be working with, right? How about the second one? What is the LCD? 18. All right. So I multiply each term by 18. This is 6. Did 18 cancel? What about 18 divided by 2? 9. So what do we have? 6x plus 7y is equal to 9. This is my equation 2. Are we okay so far? Okay. Don't you see that after you change it to equation 1 and 2, the problem gets a lot easier? Don't you think it's easier now? Okay. Then let's think about which variable do we want to eliminate. Is it x or y? It doesn't matter. So maybe x. Okay. Now, what is the least common multiple? So if I look at 8 and 6, what's my least common multiple? 24? Okay, so I need to have 24 and negative 24, right? Okay. So equation 1, what am I supposed to do with equation 1? I need 24. Multiply by 3. Okay. So 24x plus 27y is equal to 33. Okay. Now, what about equation 2? Multiply by negative 4. Because I need negative 24. I cannot have both 24. One has to be negative. So if I multiply by negative 4, I will have negative 24x minus 28y is equal to negative 36. All right. Doable? So, what is negative y is equal to negative 3? So what is y equal to? Positive 3. Yeah. Is this a yes? Easy? No, not easy, but doable though? Okay. Now, what about the x? Right. So substitute y equals to 3 to equation, either one, whichever one, 2 or 1. It doesn't matter, it's just almost the same. So 6x plus 7 times 3 is equal to 9. So 6x plus 21 is equal to 9. Now what? Subtract 21 both sides. What is negative 12? So x is negative 2. Okay. So my solution is negative 2 comma 3. Yes? Okay. Now what about number 4? Now, can I clarify anything before I move on? Is the process pretty clear? Okay. What about number 4? Oh, I don't have to clear anything. I could label this. No decimal, no fraction. I will just label. What am I supposed to do with number 4? Eliminate A or B? Either one? Okay, so eliminate B. So I'm looking at this. This is 6 and this is 3. What is the least common multiple? 6. So the equation 1 we will just copy then. Okay. 10a plus 6b is negative 8. What about equation 2? Multiply by negative 2. So negative 10a minus 6b is equal to negative 4. Yeah. All right. What happens? The a cancel. So this is 0 equals to 4. Okay. Is 0 equal to 4? Nope. So this is false. What's your conclusion? Okay. The solution. Because it's false. Yeah. All right, last one before you leave. Okay. I'm supposed to clear the decimal. How do I clear decimal? Okay. So what do I have? Negative 4x plus 7y is 13. That's right. Now I'm going to call this equation 1. How about the second one? 7x minus 3y is equal to 5. And this is equation 2. Okay. Now, which one do we eliminate? The y? Okay. Or some of you probably want x. That's fine too. So if I look at 7 and 3, what is the least common multiple? 21. Okay. So equation 1, we will multiply by 3. Because I need 21. So negative 12x plus 21y is equal to 39. So we multiply these by 3, this by 3, this by 3. How about equation 2? By 7? Okay. So 7 times 7, 49. Minus 3 times 7, 21. 5 times 7, 35. Okay, now the y's cancel. What do I have? 37x is equal to 74. So x is equal to 2. All right. Almost done. What now? Substitute x equals to equation. Let's see, which one's easier? Oh, they're almost the same. Equation 2? Yeah, okay. So 7 times 2 minus 3y is equal to 5. So 14, okay, it's too low. Let me do it on the other side. So 14 minus 3y is equal to 5. Then what? Negative 3y is equal to negative 9. So subtract 14 both sides. So what is y? 3. Alright, so solution is 2, 3. Alright. So something like this is doable? Yeah? Okay. So you have to remember something. If you have fraction, then what do we do? Clear the fraction. If you have decimals, then what do we do? Sometimes you have to multiply by 100, depending on how many decimals. Right? Okay. Yes? Okay. So you're going to have a long holiday, right? I'm not going to make it due on Wednesday. However, we're done with 8.1 and 8.2. So you're responsible to finish it. Yeah. I know some of you probably wouldn't get it by Wednesday. Oh, so will everybody get it by Wednesday? The Math Excel? Yeah? Okay, so I will close the homework 8.1 and 8.2 on Wednesday. Close meaning put the due date. They're due on Wednesday. Yeah? And on Tuesday when we come back, I'm going to do 8.4 first, which is 3 by 3 systems. Yeah, and then go back to 8.3. Yes? Okay, guys. So remember to get the Math Excel and do 8.1 and 8.2. Any questions? I'm going to stick here a little bit more. If not, I'm going to go to my office and stick there until 12:15. Yes. You can turn it in ahead of time. Like if you decide to finish it tonight, no problem. Okay, and remember the 30-minute rule. If you get stuck in one problem 30 minutes or more, then what do? You just skip it and drive the problem and ask me or your SI coach later. Okay? So don't get stuck. All right. Have a good Labor Day weekend or a spring break or whatever. No, it's not spring break. It's Labor Day. Okay. Bye-bye.
Recording, they're going to be on the website. So.
No, it's going to be, I have to give you the link. But now, remember I have the videos before.
Yeah.
From before, you can look at it also from the previous semester. They're already available.
They are in the...
It's
on Math Excel.
There is the link in Math Excel. Or remember, I showed you in my website. It's a lecture video. Then you can click that link.
Okay. And your website is in our syllabus, right?
Yeah, myonlinemath.com/M125. Remember that? You have my syllabus?
Yes.
Okay.
Okay.
It's in my website. Click lecture video. Or if you log into Math Excel, there's on the announcement.
Okay.
So I make you can find it easily. Yes. Okay. Thank you, Hector. Oh yeah, you need Atlas?
No, that's the office and the attendance class.
Oh, so they signed?
Yes.
They signed it for you? Okay, then I need your name. Okay. Does anybody need this? If not, I'm going to turn it off. This is fine? Okay. Hold, give me a second. Yeah. Let me close the recording. Okay, so we're done with 8.2, solving by substitution and elimination.